Hi everyone! Today we're going to study the parabola with vertex at the origin and opens upward. First, let us define parabola. A parabola is a set of all points in a plane equidistant from a fixed point and fixed line in that plane. The fixed point is called the focus of the parabola, and the fixed line is called the directrix. Let us draw a parabola that opens upward. First, let us draw a line and a point. The point is the focus and the line is the directrix, and this is a horizontal line. Let us find points that satisfy the condition of parabola. The first point that we can think of is the point between the focus and the directrix. And let us find more points. Here are two more points. Another points that we can think of are here. And then let us connect these points with a smooth curve. And this is now our parabola. And we put one point of the parabola in the origin. This is now a parabola with vertex at origin and opens upward. We let A be the distance from the vertex and focus. By the way, this point here is the vertex and this is our focus. And the distance is A. The coordinates of the focus is 0, A. And the directrix, the equation is y equals negative A. The line perpendicular to directrix and passing to focus is called axis. This is the axis. In this example, the axis here is the y-axis itself. So the equation of the axis is x equals 0. The intersection of the parabola and the axis is called vertex. So again, this is our vertex. The chord drawn perpendicular to axis and passing through focus is called latus rectum. This is the line segment that we called latus rectum. Let us now derive the formula. Let us pick one point of the parabola, let's say this point, and we put this as point P with coordinates xy. And then let us consider the distance from this moving point to the focus, and that is a fixed point. We denote this as d sub 1. And then we take the distance from the moving point away from the directrix. We denote this as d sub 2. By definition of parabola, we say that d sub 1 equals d sub 2. Take note, d sub 1 is distance between 2 points. So we use the formula for distance between 2 points. So we have now d sub 1 equals the big square root of x minus 0 is quantity squared plus y minus a. This is also squared equals the d sub 2, and this is equal to y plus a. Let us square both sides to simplify further. So the left side becomes x squared You see here the x minus 0 is simply x, and then this square of y minus a we simply copied here. And this is equal to the square of the right side, and that is y plus a, and it is with power 2. Simplifying further, let us expand the squares. On the left side, we have this x squared. We'll just copy. And the square of y minus a now becomes y squared minus 2ay plus a squared equals the right side is the square of y plus a. So we have y squared plus 2ay plus a squared. We can see here that there is y squared in both sides, so we can cancel that. Also, there is a squared here and here that we can cancel also. Simplifying now, this negative 2ay we will transpose on the right. So from negative, it becomes positive. So the left side now is x squared equals, the right side is 2ay plus 2ay. Combining the right side terms, we have now 4ay. It means to say, we have now the equation of parabola with vertex at origin and opens upward. Let us now substitute y equals a to get the coordinates of endpoints of latus rectum. Again, this is our latus rectum. So we have now x squared equals 4ay now becomes 4a times a. Multiplying this a and a, we have a square. To simplify this equation, let us take the square root of both sides. So we have the square root of x squared equals the square root of 4a squared. So the value of x equals plus or minus 2a. It means to say, the endpoints of latus rectum are the points 2a, a, this is the point, and negative 2a, a, that is the point. Looking at this graph, we can see that the length of latus rectum equals 4a. Take note that this 4a is the coefficient of y in the equation of parabola with vertex at origin and opens upward. Let us see this example. Sketch and discuss x squared equals 16y. For our solution, we can see that this given equation conforms with our equation of parabola x squared equals 4ay. So it means this is a parabola with vertex at origin 0, 0 and opens upward. Taking now that value 16 because that is equal to 4a, first we know that this is the length of latus rectum. And then let us solve for a. Dividing this equation by 4 because that is the coefficient of a, we will get the value of a equals 4. From here, we can say that the focus has coordinates 0, 4, while the directrix is aligned with equation y equals negative 4. We know that the axis is the y-axis itself and the equation is x equals 0. Using these initial references, we can now draw the parabola. This is the parabola x squared equals 16y. This is the vertex at the origin, the focus at the point 04. This is our line. This is the directrix. Y equals -4. And then we can now get the endpoints of latus rectum using this formula, plus or minus 2a, a. So the points are 8, 4, this is the point, and -8, 4, this is the point. This is our final answer. Hi everyone. Today we're going to study the parabola with vertex at the origin and opens downward. Let us now draw a parabola that opens downward. Here we have a line and a point. The point is called the focus, and the line, which is horizontal, is the directrix. In here, we put the line above the point. Now let us find points that satisfy the condition of parabola. It means those points that are equidistant from this point and this line. The first point that we can consider is the point between this point and this line. And here is the point. Let us find more points. Here we have 2 more points equidistant from this point and from this line. Here are 4 more points that satisfy the condition of parabola. And from here, let us connect these points with a smooth curve. And here we have the parabola. And intentionally, we put this point at the origin. There is a line perpendicular to directrix and passing through focus that is called axis. This is the axis. And in this example, the axis is the y-axis itself. So we have this equation x equals 0 for the axis. This is now a parabola with vertex at the origin, that is 0, 0, and opens downward. We let a be the distance from the vertex up to the focus. So it means to say the coordinates of focus is 0, -a. The distance from this vertex to the line is also a. So the equation of the directrix is y equals a. There is a chord drawn perpendicular to axis and passing through focus that is called latus rectum. This is the latus rectum. Let us now derive the formula. Let us pick a point of the parabola. Let's say this point. Let us name this as P with coordinates xy. And this P is a moving point representing all the points of the parabola. Now, let us get the distance of this moving point away from the focus. And we denote this as d sub 1. Also, the distance of this moving point away from the line, which is the directrix, we denote this as d sub 2. By definition of parabola, we say that d sub 1 is equal to d sub 2. Take note that d sub 1 is the distance between 2 points. So we will use the formula for distance between 2 points. So we have now the big square root of this x minus 0, and it is squared, plus y minus the negative a, which is also squared. And this is equal to d sub 2. Our d sub 2 again is the distance of this moving point away from the line, and this is a perpendicular distance, and the distance is a minus y. Let us simplify this equation by squaring both sides. If we do that, in the left side, the big square root is cancelled out. So we have now x minus 0 will just be x, and it is squared, plus the y minus negative a becomes y plus a, and also squared, equals the a minus y is now squared. Let us expand the squares. So we have now x squared, we'll just copy that, plus this square of y plus a becomes y squared plus 2ay plus a squared, equals the right side is the square of a minus y. So we have now a squared minus 2ay plus y squared. We can see here that there is y squared on the left side and y squared on the right. So we can cancel these terms. Also, there is a square on the left and another a square on the right that we can cancel. So what remains now on the left side is x squared, and this positive 2ay we will transpose on the right. So we have now from positive it becomes negative. So the right side is this negative 2ay is now copied here, and minus 2ay. Combining the terms of the right side, we have now negative 4ay. So it means to say we have now the equation of parabola with vertex at origin and opens downward. This is now the equation. Let us now substitute y equals negative a to get the coordinates of endpoints of latus rectum. Remember, this is the latus rectum. So this equation now becomes x squared equals negative 4ay, and the y becomes negative a. This negative and negative becomes positive, and a times a becomes a squared. So we have now here x squared equals 4a squared. Let us get the square root of both sides. So we have square root of x squared equals the square root of 4a squared. On the left side, we can cancel the radical and the square. So only x comes down, and this is equal to plus or minus 2a. Therefore, the endpoints of latus rectum are the points 2a, negative a, that is the point, and negative 2a, negative a, and this is that point. By this graph, we can deduce that the length of latus rectum equals 4a. And this 4a we can directly see from the equation of parabola. We'll just take the positive value of the coefficient of y. Let us see this example. Sketch and discuss x squared equals negative 12y. For our solution, we can see that this equation here falls under the pattern of our parabola with vertex at origin and opens downward. So that is x squared equals negative 4ay. We will take the positive value for a, and this is equal to that value 12. This 12 here is the length of latus rectum. We can solve for a by dividing this equation by 4. So the value of a equals 3. And from here, we can now write the coordinates of focus, and that is 0, negative 3. Also the directrix, which is y equals 3. The axis is directly our y-axis with the equation x equals 0. Given the focus and directrix along with the vertex at origin, we can now draw our parabola. This is now the parabola that opens downward and vertex at origin. The focus is here. We have the directrix above. And we can now write the endpoints of latus rectum, and this is our formula. Plus or minus 2a, that is the x coordinates, and negative a for the y coordinate. So the points are 6, negative 3, this is the point, and the negative 6, negative 3. This is the other endpoint. This is now our final answer. Hi everyone. Today we're going to study the parabola with vertex at the origin that opens to the right. Now let us draw a parabola. Here we have a line and a point. The fixed point is called the focus, and this fixed line, which is vertical, is the directrix. Now let us find some points that satisfy the condition of parabola. This is the first point that is equidistant from the focus and from the line, which is directrix. Let us find more points that satisfy the condition. Here we have two more points that is equidistant from this point and from the line. Let us find more points. So we added 4 more points here. And then let us connect these points with a smooth graph. So we have here the parabola that opens to the right. We made sure that one point of the parabola is at the origin. Now, the line through the focus perpendicular to the directrix is called axis. This line here is called the axis, which is also the x-axis in this example. The intersection of the axis and the parabola is called vertex. This is the point. This is the vertex. And remember, this vertex is one of the point of the parabola. The chord drawn through the focus and perpendicular to the axis of the parabola is called latus rectum. This is the latus rectum. It connects 2 points of the parabola passing through the focus, and this is perpendicular to the axis. This is now a parabola that opens to the right, and vertex at the origin. If we know the equation of the directrix of the parabola and the coordinates of its focus, the equation and graph of the parabola can easily be determined. We let the focus be this coordinate A0, and the directrix has the equation x equals negative a. So here we put the a0 and the x equals negative a for the directrix. Let us choose one point of the parabola, let's say this point, and we put it to be P with coordinates xy, and this point represents all the points of the parabola. And then we find the distance of this moving point to the focus, and we denote this as d sub 1, while the distance from this moving point to the line is d sub 2. By definition of parabola, we know that d sub 1 must be equal to d sub 2. If you see this d sub 1, this is the distance of this point xy from the focus A0. So we will use the distance formula between 2 points. So we have the big square root of the quantity x minus a is squared plus the square of y minus 0, and this is equal to the distance of this point to that line. So this is a perpendicular distance, so we write here x plus a. Let us simplify the equation by squaring both sides. So we have now x minus a is squared plus the y minus 0 is simply y, and we put the square. And this is equal to the right side now becomes the square of x plus a. Let us expand the squares. The left side now becomes x squared minus 2ax plus a squared plus y squared. And this is equal to the right side now becomes x squared plus 2ax plus a squared. We can cancel the x squared here and the x squared here. Also, there is a squared and there is a squared on the right side that we can cancel also. Now, simplifying further, this negative 2ax we're going to transpose to the right. So from negative, it becomes positive. So we have now the left side as y squared equals this 2ax plus the 2ax. Combining the right side terms, we have now 4ax. It means to say the equation of parabola with vertex at origin and opens to the right is y squared equals 4ax. Let us analyze further this equation. Let us substitute x equals a to get the coordinates of endpoints of latus rectum. So the y squared equals 4ax now becomes y squared equals 4a times a. The x here now becomes a. This a and a becomes a squared. Let us find the y. Let us take the square root of both sides. So the square root of y squared equals the square root of 4a squared. On the left side, we can cancel the radical and the power 2. So we have now y equals the right side becomes plus or minus 2a. It means to say the endpoints of latus rectum are the points a, 2a, and a, negative 2a. In our graph here, we can see that this is the point a, 2a, and this is the point a, negative 2a. From this graph also, we can learn that the length of latus rectum equals 4a. Look at this 4a. Let us see this example. Sketch and discuss y squared equals 8x. First, let us write the standard equation of parabola, and that is y squared equals 4ax. We can see here that the value for a, that is the coefficient of x, which is 8. So we write here 4a equals 8. We know that this value 8 is simply the length of latus rectum. Simplifying this equation now, we can get the value of a. Let us divide the equation by 4, so the value of a equals 2. And from here, we can now write the coordinates of the focus, and that is 2, 0. Also, we can write the equation of directrix, that is x equals negative 2. We can say now that this is parabola with vertex at origin 0, 0 that opens to the right. Now, the axis of the parabola is the x-axis itself, and we know the equation of x-axis is y equals 0. Now, for the endpoints of latus rectum, the points are 2, 4 and 2, negative 4. It comes from our formula that the endpoints of latus rectum are the points a plus or minus 2a. Now, using GeoGebra, let us sketch this equation. We can see here we have a parabola that opens to the right. The focus is the point 2, 0. The directrix is this line x equals negative 2. The vertex is at the origin. The axis of the parabola is the x-axis itself, and the equation is y equals 0. Look at the endpoints of latus rectum. The point 2, 4 is here, and the point 2, negative 4 is here. Again, the length of this latus rectum was derived from the beginning, and that is 8. This is our final answer. Hi everyone. Today we're going to study the parabola whose vertex at the origin that opens to the left. Let us draw a parabola that opens to the left. Here we have a point and a line. Take note, intentionally we put the point on the left side and this line on the right. This fixed point is the focus, and the fixed line, which is vertical, is the directrix. Now, let us find some points that satisfy the condition of the parabola. The first point is the one between the focus and the directrix. Let us find two more points, and these are the points. Let us put four more points, and these are the points that satisfy the condition of the parabola. Let us connect these points with a smooth curve, so we have now the parabola. Intentionally, we put one point of the parabola in the origin, and that is 0, 0. Now, there is a line that passes through the focus perpendicular to the directrix, and that is called axis. This is the axis. In this example, the axis is also the x-axis. The intersection of the axis and the parabola is called vertex. This is the vertex. The chord drawn through the focus and perpendicular to the axis of the parabola is called latus rectum. This is the latus rectum. It connects 2 points of the parabola. This is now a parabola that opens to the left and vertex at the origin. We let A to be the distance between vertex and focus. It means to say the focus has the coordinates now negative A, 0. And the directrix has equation x equals A. We take one point of the parabola, say this point. We put this P with coordinates xy. And this point represents all the points of the parabola. We're going to take the distance of this moving point and the fixed point focus. We denote this as d sub 1. Also, we take the distance of this moving point away from the directrix. By definition of parabola, this d sub 1 is equal to d sub 2. Take note, d sub 1 is the distance between 2 points, so we use the formula for distance between 2 points. So we have now the big square root of this x minus the negative a, and the quantity is squared, plus the y minus 0, and this quantity is squared. For the right side, this is equal to d sub 2, and that is the distance from this point to the line. So we have here a minus x. Let us square both sides. So the left side now becomes x plus a. So this minus and negative a now plus a. And the quantity is squared, plus y minus 0 is y, and this is squared, equals the right side a minus x is squared. Let us expand the squares. So the left side now becomes x squared plus 2ax plus a squared plus y squared, equals the right side is a squared minus 2ax plus x squared. We can see here this x squared and the other x squared on the right side can be cancelled out. Also, this a squared can be cancelled out with the a squared on the right. Now let us simplify further. This positive 2ax we will transpose to the right. So we have now y squared equals negative 2ax, and now negative 2ax. Combining the terms of the right side, we have y squared equals negative 4ax. This is now the equation of parabola with vertex at origin and opens to the left. Now let us substitute x equals negative a to get the coordinates of endpoints of latus rectum. So this y square equals negative 4ax now becomes y square equals negative 4a times x, and the x now becomes negative a. This negative times negative becomes positive, and a times a is now a square. So we have now y square equals positive 4a square. Let us take the square root of both sides. So we have the square root of y square equals the square root of 4a square. On the left side, this radical sign and the power 2 can cancel each other. So we have now y equals plus or minus 2a. So the endpoints of latus rectum are the points negative a, 2a, and negative a, negative 2a. This point here is the negative a, 2a, and this point here is the negative a, negative 2a. By this figure, we can see that the length of latus rectum equals 4a. We can see here that this 4a is familiar to our equation of parabola, and that is the coefficient of x. The only thing is it is positive. Let's have an example. Find the equation of the parabola with vertex at origin and focus in negative 5, 0. Sketch and discuss the graph. For our solution, we know that a is the distance between vertex and focus. And since the origin is the vertex and the focus is at negative 5, 0, it means a equals 5. From here, we can say that the parabola has the vertex at origin and opens to the left. Writing now the general equation of the parabola, this is now y square equals negative 4ax. Let us substitute the value of a as 5 in the equation. So we have now y square equals negative 4a, now negative 4 times 5 times x. So we will multiply this negative 4 by 5. We have now y square equals negative 20x. This is now our answer. This is the equation of the parabola with vertex at origin and focus in negative 5, 0. Let us now sketch the graph. Using GeoGebra, this is now the parabola y square equals negative 20x. Let us now discuss the graph. The vertex is at 0, 0. That is the origin. The focus is here, the negative 5, 0. The line directrix has the equation x equals 5. The length of latus rectum equals 20. That is the positive value of the coefficient of x. The endpoints of latus rectum are the points negative 5, 10 and the point negative 5, negative 10. This idea comes from the formula a plus or minus 2a. The axis is the x-axis itself, and the equation is y equals 0. This is our final answer. I hope you learned something from this video. See you again next time.